Continuing with the empirical rule. So remember in the last video I showed you how to compute these percentages in different cases for different numbers, and also to find out if the percentage is given, some percentage is given, then we have to find the number which represents that percentage. Now these numbers that we are talking about, these are actually z-scores. So on the horizontal line, the numbers that I am writing, these are z-scores. So if you notice here, so we are talking about z equals to 1 when we are at mu plus sigma. So mu plus sigma gives us z is equal to 1. Okay, let me write it like this. When, oh not when, okay, mu plus sigma, this implies z is equal to 1, and you can easily check it. I will show you in a minute. Mu plus 2 sigma will mean z is equal to 2, and mu plus 3 sigma means z is equal to 3. And in the same way, if you have a minus sign here, then it will mean that z is equal to plus minus 1. Okay, so when mu is plus 1, mu plus sigma, you have z is equal to plus 1. When it is mu minus sigma, you have z is equal to negative 1. And in the same way, when you have the z, mu is equal to mu plus, when you are at mu plus 2 sigma, then z will be sigma. But if you are at mu minus 2 sigma, then z will be negative 2. So I can write it like this. In the same way over here, if I have a negative, then z will be equal to 3, plus minus 3. So which tells us that we are talking about the z-score on the the horizontal line. So, but we can at this moment only talk about these 6 z values, but z values are infinite. So like in between here somewhere, so this is our mean. This will be mu plus sigma, let's say. So what about a number here or a number here? In the same way, any number on the, what about that? Like I can, if I have a z value over here, I can draw this line. So I want to talk about this area. So this will, we cannot calculate it yet. This is something we will learn in chapter 6. So it will be very similar to what I am showing you here, but we are now at these only 6 z values. Okay, we can calculate it. So let me show you. So if I have my x, so these values that we are talking about, these will be our x value. So if I am at x is equal to mu plus 2 sigma, let's say. So if you recall, in order to calculate the z-score, you say z is equal to x minus mu over sigma. So if I, in place of the x, I replace it by this, again mu plus 2 sigma minus mu whole divided by sigma. Now mu and mu cancel out, and we are left with 2 sigma over sigma. Sigma and sigma cancel out, so I am left with 2. In the same way, if you can put any of other 5 values, we'll get plus 1, plus or minus 1, plus or minus 2, and plus or minus 3. So what we do here, when we are looking at these values here, because we have this known that with the standard normal distribution, your mean is going to be 0. Mean is going to be 0, and your standard deviation is going to be 1, and then 2 and 3 And similarly on this side, -1, -2, and -3. So when we are taking this one, so actually the area that I'm talking about, that is we get it from the standard normal. So there is a table which we can look up and find any other z value that we want to, which is something again you will learn in chapter 6, how to look up in the table and get the z value or get the area corresponding to a certain z value. So anyhow, so this is how it works. So let's look, yeah, one more thing. So this curve or this picture, so when you get a question in the exam, it's your choice. You can make something like this or draw something like this or something like the one we have here at the bottom. The only difference between these two is that over the horizontal line, here I have the z scores, the 0, 1, 2, 3, and the -1, -2, -3. But in the second picture, I have the actual values of the actual distribution or the problem we are given. So the mu and the sigma, with the mu and the sigma values. So if you draw this, if you can memorize these numbers over here and just draw this and then answer whatever question is asked, it's fine. It's totally fine. Okay. But if you don't want to memorize these numbers here, at least you must know what do we mean by 68, 95, and 99.7. So what do they belong to? Okay. So remember, this is between sigma, mu minus sigma and mu plus sigma. So one standard deviation away from the mean. And then we have mu minus sigma, mu plus sigma, and then we have the mu plus sigma and mu plus 3 sigma and mu minus 3 sigma. So you have to remember this, that the 68% is between. So in the case of the normal distribution, so this lies between -1 and 1. This lies between -2 and 2. This lies between -3 and 3. Okay? But in the case of general distribution, any distribution, this is mu minus sigma and mu plus sigma. Mu minus 2 sigma, mu plus 2 sigma, and so on. Mu minus 3 sigma and mu plus 3 sigma. So you can do this, or you can just not draw this, just remember this thing and then do the calculations according to what has been asked. So I'll show you both ways. Let's look at this example. This is saying IQ scores have a bell-shaped distribution. So whenever your question tells you that it has a normal distribution or bell-shaped distribution, okay, then you can do this, what we are going to do right now. So we have that our mu is 100 and our sigma is 15. So at least you should be able to see that we have mu plus minus sigma is equal to, so if you do well, okay, I cannot do that together, I have to do it separately. Okay, so mu minus sigma will be equal to, in our case, 100 minus 15. Yeah, 100 minus 15, which gives us 85. Mu plus sigma, this gives me 70. Sorry. Okay, now again, it depends on how we are writing. So mu plus sigma will be 115. Mu minus 2 sigma will be equal to 70, and mu plus 2 sigma will be equal to 130. Then mu minus 3 sigma will be equal to, So mu minus 3 sigma will be equal to 70 minus 15 will be 655, and mu plus 3 sigma will equal to 145. Okay, so now keeping this in mind, now I can answer these questions. So it says find two numbers between which middle 68% of the IQ scores will lie. So middle 68%. So remember, so it's always a good idea to draw these normal curves so that we can see that understand what you are doing. So basically, you will draw this and shade this. So it means, so this is mu minus sigma, which is, we can look up there and it is 85, and this is 115. So now you can just write the number. So this will be, answer will be 68%. Okay. Or you can do this, that well, I think this is okay. This is good. What percentage of IQ scores lies between 70 and 130? Now notice here in the A part, percentage was given and you were asked to find the numbers. Sometimes it might say find the range of numbers. So basically it means from 85 to 115. That will be the range. Okay, so here we are asking, so they are saying 70 minus 130. So what does that mean? It means they are saying 70. What is 70 up there? 70 is mu minus 2 sigma. And then mu 130 is mu plus 2 sigma. So we are, so you can write here 130 and 70. Get this, and this is going to be 95%. Okay, looking at the next one, what percentage of IQ scores are greater than 145? Okay, greater than 145. So you will do this, and now 145 is somewhere here. So we want this, the percentage over here, which means we want the area over here. So that is what I was saying. If you have drawn this in the beginning over here, before you answer the questions, you can just look up. So we are talking about this, so you can write the answer. But if you don't have this, then you have to do a little bit of work in this problem. So you will say from here to all the way to the right. So this is 100. So from 100 onwards, you have the area will be 50% minus. Now you will subtract this area. So we are taking this much. So we are taking all the area from the right, on the right of this line, middle line. So it is 50%, and then we subtract the half of the 99.7. So 99.7% divided by 2. So you get 50%. Or you can, if you don't, this is like mostly we write in algebra. But if you don't want to be that, particular, you can do this. So this, we know that 99.7 is involved here because 145 is mu plus 3 sigma. So this will be, so 99.7% will be equal to 49.85%. Okay, so then you can say 50% minus 49.85%, which is equal to 0.15%. Yeah. What percentage of the IQ scores are less than 115? Okay, so again, draw this. So 115 is over here. That is 1 standard deviation above. So we want this area because we want to be less than 115. So it means this area plus this one. So remember, this is middle line. this one. So on the left is 50%. On the right here is, if you recall, 34% because it's half of the 68. So it means our area will be 50% plus 34%, which is 84%. Okay. Then it is what percentage of IQ scores are greater than 85. So greater than 85, so this is 100. 85 was 1 standard deviation below. It is the same thing as we were just talking about above. So we are now talking about, so this is 85. We are talking about this area. So this will be the same thing because this is now, this is the middle. This is the middle. So on the right, we have all the area. So it means we have 50% here. And this one is 34%. So you will say again 50 plus 34 equals 84%. Okay, next is what percentage of IQ scores are greater than 130 or, so this is important, or less than 55. So when you draw your picture, so what we are looking at, okay, let me draw this middle line with the red. This is the middle line. So we are saying 130 less than 1, greater than 130. So 130 comes here at the 2, mu plus 2 sigma. So this is 1, this is 2. So we are talking about greater, so this is 130. And then let me draw the other pictures here. So, and then we are at 55. So we are talking about this area. So this is coming after 2. And this is coming after actually 3. Maybe we can write, keep left, we can write it, we have to write it over here because it's after 3 standard deviation, but on this right hand side after 2. So we are talking about this area less than 55 and greater than 130. Now less than 55 we know is 0.15, but over here this is not 0.15. If you recall, this is 2.5 because so how do you get the left area? If this is mu minus 3 sigma, or in our case 55. So if you recall what we do, we have 100 minus 99.7%, which is going to give us 0.3%, and then we divide 0.3% by 2 to get 0.15%. So that is this area. Okay, and for the right one, I don't have much space here. Okay, so for the right one, do the same thing, and now you are at 130, which is mu plus 2 sigma. So this area is going to be 100 minus 95, which is 5, and then divide 5 by 2, so 2.5. So this area is 2.5%. So our final answer will be 0.15% plus 2.5%, which is 2.55%. And now the last part, what percentage of I scores are greater than 100 and less than 145? So now we have greater than 100 means to the right of 100 and 145. So 145 is coming at 3 standard deviation. So it means the area between here, which we already know. And if not, then what you do is 100% minus 95%, which is no, sorry, yeah, 5%. And actually, my bad. Basically, we just divide the 95 by 2. That's all we do. Oops. So this is how you do this problem. Okay, now the next one. So it says the distribution of weights of new. Now, by the way, in the exam, we won't give you this many parts. There would be like 2 or maybe 3 parts, like in this next example. Actually, this second example is taken from one of the old exams. So it says the distribution of weights of newborn babies is bell-shaped with a mean of 3,000 and a standard deviation of 500 grams. So these are in grams. Okay, so now the part is saying so this says what percentage of newborn babies are weigh between 2,000 and 4,000 grams. So what we do is you find out what is 3,000. 3,000 is one two standard deviation below the mean. So you can say 2,000 is equal to mu plus 2 sigma, or you can just say is equal to, or even, it's again your choice. You have to somehow write something here. So our mu, which is 3,000. So when you have 3,000, you add this, you get 3,500, and then you add 500 again, you get 4,000. So this number is achieved. And now because 2,000 is less than the mean, so it means we have to subtract something from the mean. So what can we subtract? The only thing we are allowed is to subtract the in this problem, subtract the standard deviation. So minus 500, but that won't get you to 2,000. You have to subtract 500 again. Okay. So what does that mean? That z is between -2 and 2. So which means, so you can do this. So which is 95%. Or if you have drawn that curve, wait a minute, no. So if you have that curve drawn here, so 3,000, 3,500, 4,000, then 4,500. And the same way you will go to the left. Yeah. And then all these areas are known. I think it's like 13.5% or 13.4%. Yeah, we'll check. So whatever we have on the right side, you will get the same thing on the left side. See, I don't remember those. So this is 13.5% and this is 34%. This is 2.35. I think I messed up there. Yeah, this is 2.35. And this one is 13.5%. And so on. And on the left hand side, the same number repeat. Then you can answer them directly. So because they're asking way less than 3,500. So 3,500 is over here. So if we are talking about all these areas, this area, this area, this area, this area, this area. So if you have to add up all these numbers, so it will be 0.15 plus 0.2 plus 2.35 plus 13.5 plus 34. So you get the okay, there is more 34, right? Plus 34 again, because this gives us 50, should give us 50, and then plus another piece, because we have this is mean. Anyhow, so if you want to do it that way, you may, but I prefer the other method in which we draw every time we draw the new curve and we talk about the area we are looking at. So I would do it this way. So, and then 3,500 is one standard deviation below. A little bit bigger curve is better. So we are talking about this area. So this much I know is 50, and this is 50, and this is 34. So I can do 50% plus 34% is going to give me 84%. Oh, I could have done it over here. Anyhow, the C part calculate the range of birth weights. Now range here doesn't mean the highest minus the smallest, as you learned in chapter 3. So range of the data, that is different. This range is just like between which two numbers weights lie. And okay, 68%, we already know. So the answer will be 2,500 grams and 3,500 grams. So that will be the answer, and that's all. So this is how you do these problems.